So this is lesson number 40 in Algebra 2, abstract fractional equations. And they call them abstract because there's no numbers in these. Absolutely none. It's just all a bunch of letters. And what we're doing is we're learning a procedure, so you don't need numbers to learn a procedure. So, for example, if I have the example 40.1 a over x, and I'm adding m over a, and I say that equals c. Boy, that's crazy. Not a single number in there. And what they're asking us to do is set this equal to x, so that when we're done, it's going to say x equals blah, blah, blah. So that's what we're doing for this. Let me put my x back down there. So, one of the things that's really, really important to either put down in your notes or put it in your brain so you remember, we can very easily get rid of fractions as long as we have an equal sign. Okay, this is what we do. If we have an equal sign, we find the common denominator of our fractions, which this is c over 1. Common denominator of our fractions would be a x, correct? Remember, I told you that if we want to find common denominators, we look here and see what we're missing that we have over here. Oh, we have an a, so we put an a over there. Here we have an a, but we don't have an x, so we put an x there and up there. So we have an x up there and an x down there, an a up here and an a down there. Now we have common denominators and we can add. Okay, same kind of thing, but when you have an equal sign, you take that common denominator and you pull it out and multiply the entire equation, including both sides of the equal sign. And that will make all of your denominators go away. Because look what we have. Okay, see what I did? I multiplied this times this. A times a is a squared, and the x drags along. This one I can't combine, nor can I combine anything here. Now I can cancel those two, those, and the 1 just doesn't even need to be there. And I have a squared plus xm, and I get that. No fractions. So it makes it a lot easier then to go ahead and solve this. Okay, so the next step is, in this case, we're trying to solve for x, right? So we're going to get all the terms with an x in them on the same side of the equal sign. Okay, notice what I did here. I had to take this whole thing. I can't just take the x. These are together. I have to take the whole thing, and I subtracted it and moved it over here. So there's where my minus xm is from. Okay? So let's see if we can move some of this stuff on them down so I can have more room. Alright, next step. I have an x common here and here, so I'm going to pull an x out. Like that. Now, I need to get rid of that so I can get x by itself. Well, how do I get rid of that? I divide both sides by what I'm trying to get rid of. Those go away, and I'm left with x equals a squared over ac minus m. And that's what I was looking for. Solving it for x. Alright, let's try the second example here. And a little bit more practice here. So we have x over m plus c equals y over a. Okay, again, first step, common denominator. Common denominator is a times m. So we're going to multiply the whole thing by am. I just put it there because I didn't have room on the left of it. But I don't like it there, so let's make room. A m. Okay, so let's multiply it by each of these terms. Alright, so am times x over m is a m x over m, and multiply it by c, and multiply it by the y over a. and then I can cancel. cancel those, and I'm left with ax plus amc equals my. I don't even know what I'm looking for. Oh, I'm solving it for m, so I've got to try to get m by itself. So all the m's go to the same side. So that's how I knew to move this one over, is because it has an m and I needed it on the same side. So I have ax, and those cancel. Okay, now I look at this, and I factor out an m. I factor out what I'm looking for. Okay. Then I divide both sides by that. And when I do that, that all goes away. And there I've got it. M equals ax. I'm just switching it around here. And I am done. So let's do one more, and then we'll call it good. And we'll do example 40.3. We have 6 over p minus ax equals m over y plus k. Alright, so common denominators, p times y. Make a parenthesis, py. Multiply, this times this, 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 and that. So we have 6py over p minus pyax equals pym over y plus pyk. Then we cancel. This is the reason we multiply by it, so we could get rid of our denominators. You will always be able to get rid of your denominators. If you can't, then you did something wrong. And so that leaves me a 6y minus pyax equals pm plus pyk. Alright, so I'm trying to solve this for p. So that means I've got to get all the p's on one side, so I need to add this whole thing to both sides. And when I add that to a negative, that goes away. In fact, maybe I should. And then I have 6y equals pm plus pyk plus pyax. Alright, now the next step is to pull the p out, because it's common to all three of those, because I moved it over there so that I would have them all together. Okay, so this part right here is in the way of my p being by itself, so I make a long parenthesis and I put it over here. Divide both sides by that whole thing, and that one goes away. So my p then equals that. Okay, so these are not bad. You just have to remember to follow the rules exactly, and then you will be fine. And that's it.